Hello and welcome to 9.4. Here are the answers for 9.3 where we were working with special products with polynomials yesterday or the day before. So there's your answers. Let me know if you guys have any questions. And those are repeats. Okay. All right. We're going to be solving polynomials in factored form today. So there's two new skills that we're going to work on. We're going to work on solving polynomials in factored form, and we're going to learn actually how to factor out a monomial out of a binomial. So that's going to be a new skill, two new skills. And then we're going to work on this. We're going to work on a little more of that tomorrow. I'm going to do 9.4 day 2, and I might even do a 9.4 day 3, working with some word problems for you guys. So we're going to just first start with, they're going to be in factored form already. And what I mean by that is they're going to either look like this here, or they're going to look like something like this here. And so this is what I mean by factored form, and you might not know what that means yet, but I'll explain what that means. So last year, or at some point, you learned this property of 0. If I have one number times 0, it always equals 0. So we're going to use this thing, it's called the zero product property. If A times B equals 0, then one of the two numbers has to be 0, either the first number or the second number. So use this when one side of the equation is 0 and the other side is a product of polynomial factors. The solutions to these equations called roots. You're going to see this vocab word roots come up. You'll either see roots or you'll see the word zeros. I don't know how to spell zeros. That's a weird word. Or you'll see solutions. Find the solutions. Bad at spelling. I think it's no. I don't know. Hopefully somebody can correct me. All right. So use the zero product property to solve this equation here. All right. So what we got going on? I should put this here like this. Okay. So either this is our A right here times B equals 0. These are called factors. It's one number, a factor. So like, let's talk about this first. Factors of 6. 3 times 2. Those are two factors of 6. 3 times 2 equals 6. It's the two parts that multiply to the number. So these are the factors. X minus 4 equals 0, or x plus 2 equals 0. So we'll just add 4 to both sides. We'll solve each one of these equations. X equals 4. And we'll subtract 2 over here for this one. X equals negative 2. So the two solutions to this equation are 4 or negative 2. Now you can check your answer, and you might see the word roots. You might see the word zeros. Now to check your answer right here, check using substitution. You can plug in 4 and you can plug in negative 2 one at a time and see that it works. So when I plug in 4 into the original equation, so that becomes a 4 and that becomes a 4. So you have 4 minus 4, this part gives you 0. 4 plus 2, that gives you 6. 0 times 6 is 0. And then we'll plug in negative 2. So we plug in negative 2 there and negative 2 there. So negative 2 minus 4 is negative 6. Negative 2 plus 2 is 0. Negative 6 times 0 is 0. So it shows you that it works. Okay, so here's a couple more problems. Now, you might say to yourself, well, all right, x minus 7 times x plus 3 equals 0. Well, Mr. Drexler, don't I just do the opposites? Well, 7, negative 3. Those are the answers. Okay, because 7 minus 7 is 0. 0 times, if I plug in 7 for the other one, 10. 0 times 10 is 0. And then plug in negative 3. Negative 3 minus 7 is negative 10. Negative 3 plus 3 is 0. Negative 10 times 0 is 0. Yeah, they're just the opposites. Okay. Well, that works to an extent, but then you get to problems like this here, and you might take a look at the second factor and say, well, that is 3. And then you might take a look at this one here, and you're like, oh gosh, -8. Just take the opposite of 8. Well, that would be wrong. So they get a little more complicated. So we actually have to do some solving here. 4x plus 8, we want to set that equal to 0. And this one's a two-step equation. This is used when you can't just look at it and quickly identify what the root is. This one would be x equals -2. So -2 is your answer, and then 3 is your answer. And you might say to yourself, well, okay, you probably looked at it and said 4 times -2 is -8 plus 8 is 0. Okay, yeah, all right, I see that. But then let's take a look at these problems over here. You can't just plug in a whole number to get 4x plus 7 equals 0. You can't plug in a whole number in to get 2x minus 3 to be equal to 0. They're going to be fractions, and that's going to happen. So that's why we need to know about this technique. So I'll subtract 7, and then I'll divide by 4. So x equals -7/4. And that's one of your solutions. Or 2x minus 3 equals 0. Add 3, divide by 2, so I should put a plus 3 there. And x equals 3/2. So that's why you need to know this technique, because they're not always going to be easy. All right, factoring. Now we're going to work on factoring, actually getting them to look like that, because they're not always going to look like that. Oh, and I want to do one more question here. If it's, I showed you this at the beginning of the video, something like this here. If it's like this, you set 2x equal to 0, or x plus 3 equals 0. So these are so simple that they seem difficult. And the reason why they're so simple is because one of the answers is 0. So I would put a star in your notebook and make sure this example is in there. They're so easy that students don't know what to do. So 2x equals 0, or x plus 3 equals 0. So I just wanted to make sure I did one of those examples. All right, let's get into factor. We're going to factor out the GCF, greatest common factor. So you guys have done this in pre-algebra. And to factor it, you break it down. 12 breaks down into 12 times 6, or 2 times 6. 6 breaks down into 2 times 3. 42 breaks down into 2 times 21, and 21 breaks down into 3 times 7. So what you're going to do to figure out what the greatest common factor is, figure out what's in common. There's a 2 in common, and there's a 3 in common. So the greatest common factor of 12 and 42 is 6. That means I can divide 6 out of both numbers evenly. It's the largest number that you can divide out evenly. We're going to be using that skill for things that look like this. So if it says factor out the greatest monomial factor, it means factor out the largest amount, the largest number, and the largest variable that that divides out both. So for 12 and 42 is 6 and 6, and so you're going to divide that out. So you're going to divide out a 6, and you're left with 2x plus 7y. The variables x and y have nothing in common, so we just leave those as is. So basically this is like reverse distributive property. Instead of multiplying the 6 into both of these numbers to get the original expression, you're dividing the 6 out. Okay, so here's another one. All right, so I'm going to take a look at 4 and 24. The GCF out of 4 and 24, GCF of 4 and 24 is 4. I can divide 4 out of both of those. And the largest amount of powers of x is x to the third. So the GCF of this is 4x to the third power. All right, so now to do this, what we're going to do is we're going to divide 4x cubed out of both of these. So 4 divided by 4, and that's going to go on the outside. 4 divided by 4 is 1. X to the fourth divided by x to the third is x. So you have 1x. And you see how that is a whole number? X is a whole number. And then 24 divided by 4 is 6. And then x to the third divided by x to the third divided by x to the third is just 1. And so you have just had 6 left over. All right, let's take a look at this one here, 14m plus 35n. The largest number that comes out of 14 and 35 is 7. And m and n have nothing in common, so we're just going to divide 7 out of both. And we're going to have 2m left over. And we're going to have 5n left over. And you can always check these answers to see if you've done them right by using the distributive property. So check. This is to check. 7 times 2n is 14m. 7 times 5n is 35n. And that is what we started with. I would like to do one more problem just to kind of make sure that you guys are picking up on this. Let's do 15x to the third plus, we'll do 25x to the fifth. Okay, so the largest number that comes out of 15 and 25 is 5, and the highest power of x's that divides out evenly is x to the third. So that's what we're going to divide out. So we're going to put that on the outside. And then we're going to divide by 5x cubed, and we're going to divide by 5x cubed. So that leaves me with 3 plus, and then 25 divided by 5 is 5. X to the fifth divided by x to the third is x to the second. So you're using a lot of what we learned in chapter 8, actually. Okay, that's what I got for you guys. Here's your assignment. We're going to apply what we just learned in day 2. So there's day 1. Thank you guys for tuning in to 9.4 day 1.